A lot of times we'll have a set of data and we want to find one number that best represents that entire set of data. This is called finding its measure of center. There's actually quite a number of different measures of center. The one we're going to talk about in this video is called the median. And so let me show you what it looks like here. Let's say we have just a lot of data points. Let's say that these are test grades from students on their last algebra test. And some students did well, some students did not do so well, and we have everybody in between. So if I wanted one number that best represented how the class did, that would be called finding its measure of center. And like I said, the median is one of the types of measures of center. All right, so let's talk about median specifically. The median is we'll call it the middle value if you list your data points in order from lowest to highest and then literally find which one happens in the middle. So the way we typically do this is you take your data points, and very often they're not in order. Like here, they're just listed in order. They're not listed in any particular order. So we'll need to take them and sort them from low to high, which I've already done here. And then you're going to start with the low and the high. And if you were doing this with literally pencil and paper, you'll take your fingers and put your fingers on the low and the high, and then you'll start moving in towards the center. Now, if I could have listed these all on one row, I would have done that, but my screen isn't that wide, so I actually had to put them on two rows here. So 49 is paired with 99, and then we'll start going into the middle, so you'll watch the yellow lines move. Then we'll have 54 paired with 95, 65 with 92, and so on and so forth. We're moving in. All right, and then now we're at 76 paired with 88, and then the next one will be at 82 and 85. So now this is a strange situation. There's not a middle value. When there's an even number of terms, which is our situation here, when there's an even number of terms, we're going to take the average of the middle two terms because there's not a single middle term. When you have an odd number of terms, then it's obvious. Then you just land on the middle term, and that's your median. So here, the number of elements that I have, the number of test grades that I have is 16. That's an even number of terms. So what I'm going to do is I'll take 82 and 85, and I'll just average these two. And in fact, I'll do that right now. I'll take 85 plus 82, and I'll divide that quantity by 2. So this would be 167 divided by 2, which would give me 83.5. So 83.5 would be the median of this data set. Now the median has a lot of nice benefits to it. The most notably is the fact that it's not affected by outliers. Here's an example. Let's say maybe a couple of these students, maybe this student here, maybe the 65, maybe he actually didn't come to school that day, and instead of getting a 65, maybe he got a 0 because he wasn't present. Well, if we were doing one of the other measures of center, maybe like the mean, this 0 would affect your measure of center. But really, should this guy really affect dramatically the representation of the entire class? No, if you randomly selected a student, chances are they would still be in the 70 to 80 range, right? So we don't want outliers to like 0 to drastically pull down the measure of center for the entire data set. But if you look at this in the context of the median, here, I'll put this back on the screen here. If one of these quantities was a 0, or even if you had to list it first or whatnot, that wouldn't affect your median. Your median would still be 83.5. So it's what we call robust. It's not affected by outlying values. Okay, so anyway, that's the median. Now we've got some more measures of centers coming up that we're going to talk about as well in the next videos.